Hello everyone, welcome to yet another video of Smart Grid. So in this video series we are discussing about the protection and control of microgrids. So in the first video we have seen about what is microgrid, and then we have discussed about what are its components of a microgrid, and in the previous video we have discussed about the need for protection in a microgrid. So in today's video we are going to discuss about the types of protection schemes we can give for a microgrid, along with the microgrid control strategies and islanding and grid synchronizations. So let's dive into the topic. First we will see about the types of protection schemes for smart microgrid. So in the previous video itself we have seen about the need for protection, why we need to give a microgrid a protection, because it faces a lot of issues in providing a reliable operations. So in order to ensure proper reliability, seamless operations, safety and all, we need to give microgrid a protections. So now we will discuss what are the protection schemes we can offer for microgrid. First thing, we can provide a overcurrent protection. That is the main protection scheme we can give for any equipment or a grid, or which is a conventional grid or maybe a smart grid. For any equipment, overcurrent protection is highly demanded, because using those protection scheme only we can handle excessive currents. So a overcurrent protection scheme uses circuit breakers and relays to handle excessive currents. The next protection scheme we can offer is differential protection, wherein which it detects internal faults by comparing current at two ends of a lines. So any internal faults within any equipment or any zone can be easily found out through differential protections. Then we can offer distance protections, which measures impedance, change in impedances in order to detect the faults in transmission lines. So distance protections can be applied for transmission lines. We can also provide adaptive protection, which adjusts settings dynamically based on grid conditions. So adaptive protections is like a flexible mode of protections which will upgrade itself based on the dynamical conditions of the grid. And then we can provide, which is the important protection scheme for the existing smart grids and microgrids, which is the communication based protection, because in the previous grids, that is the conventional grids, there is a lack of communication. We always have a one-way communication from the utility to the consumers, but now there is a two-way communication because of the incorporation of digital technologies. So there is always a data exchange between the devices in a smart grid and microgrid as well. So we have to provide proper communication based protections, because it uses data exchange between devices in order to improve the response. Faster the data exchange, then the response will be faster. So this communication based protection is needed in order to avoid cybersecurity threats. Now we will see what are the microgrid control strategies. What are the control techniques we can offer for a microgrid, or it has, we can discuss now. The first thing is it has a centralized control. There is a one main controller or the master controller which manages the power flow and grid integration. So all the power flow and line currents, voltages and all will be controlled by this main controller, which is the master controller. And we also have decentralized control, because microgrid is mainly a decentralized mode of operation. So because microgrid will be it is concerned for a localized group of power generators, for particularly meant for distributed power generators. So each generator unit will be connected to a microgrid, a localized microgrid, and each microgrids will have its own decision making systems, which makes it to operate independently. So that is why we have a decentralized control in the microgrid also. And we also have hierarchical control, because because in order to respond to the any fault or any conditions which is of utmost priority, so based on the priority, the microgrid has to respond and take decisions. So it is a combination of centralized and a decentralized approach for efficiency. And we also have multi-agent system control strategy, which uses AI technique, artificial intelligence, and IoT based intelligent controllers for dynamic operations. Now we will see about what are the islanding and grid synchronizations uh, that can be done through microgrid. First, let's see what is meant by islanding mode. A microgrid can operate separately, that is standalone operation. So when it is connected from the micro main grid, it will operate in islanded mode, that is it will operate as a standalone grid, generating power and also transmitting and distributing to the consumers. So this is called as islanding mode. But what are the challenges in this islanding mode? There is a frequency and voltage instability, just like the other grids, because we are connecting a lot of distributed power generation into a microgrid, where in which the voltages and frequency will not be the same. Like I've already discussed, we know that the uh, voltage level for PV is different compared to wind. So voltage generations. So since we have different voltage range being, or different ranges of EMF being generated from a wind generator, and also a PV panel will generate a different form of energy, so we cannot just like that combine it into a microgrid. We have to undergo certain power electronic energy conversions, so that we can make it possible for synchronization. Even in that case also there is a frequency and voltage instability, so it makes the uh, system more unstable. And also fault isolation, that is also a big challenge for microgrid. And also reconnection delays. And we have grid synchronization, which means that connecting the microgrid to the main grid, that is a synchronization. And also connecting the energy sources to the microgrid, that is called as synchronization. So may we know that what is the main condition for synchronization? We need the voltages has to be same, whatever equipments or whatever sources we are going to connect through a microgrid, the sources should have, the output of the sources should be have same voltages, and the phase sequence should be same, and also the frequency should be same. So these three parameters has to match in order to go for synchronization. But that is not that much easy. Like we have already told, there is, we have PV and wind, and we have even we have micro turbines, we have hydros, and or fuel cells, which are also all a form of distributed power generations. So these kind of distributed power generators has to adapt to these synchronizations. So for to rectify this problem, we can provide with advanced inverters and controllers in order to ensure smooth transitions from one voltage from one mode of power to the other, so that we can make synchronization easily achievable. Now, what are the challenges in this microgrid protection and control? The first is variability in renewable sources. Yes, we have unpredictable power fluctuations, because a solar power cannot be available in the night. A wind power cannot be available all the three. We cannot expect wind power to be available 24/7. It will be based on the availability of wind. So there is a variation of power from the different renewable sources, which is a big challenge for microgrid. And also coordination of protection devices. We have lot of relays and circuit breakers and sensors. These has to be operated in a very coordinated manner. So there is a complex relay settings, and there is a possibility for misoperations also. Next, since it handle lot of data exchanges, there is a possibility for data breaches in digital systems. And also hacking is very often can be occurred in a these kind of digital technologies. So these cybersecurity threats needs to be, it's a big challenge for microgrid in protection and control. And also investment in advanced controllers, as we have seen in the previous slide itself, we have seen that synchronization, in order to provide synchronization, we need advanced controllers and communication systems, for which we need to invest more. And also regulatory barriers, we have already a set of rules and protocols. In order to implement this microgrid, these rules and protocols place a barrier for these implementations. So the compliance with the utility grids and standards and policies is a big challenge for this microgrid protection and control. So when these challenges are met, then the protection and control of microgrid is highly possible, and we can expect 100% reliable operation from these microgrids. So in this video, we have discussed in a depth about what are the protection schemes available for microgrid, and we also seen about what are the controls we offer for a microgrid, and then the challenges we face in the protection and control of microgrid. Hope this video series is very useful to you. In the upcoming video series, we will see even more details about microgrid in detail. Thank you. Thanks for listening.